Deja vu is a common occurrence for most of us in our day-to-day lives. We see it in movies like The Matrix or Back to the Future. In recent years, we've expanded our appetite for deja vu in a phenomenon we call glitches in the matrix, where we were sure that we put an object somewhere but it turns up missing, or we perfectly recall a scenario that never happened in our timeline. This feeling is related to the Mandela effect, where people misremember brand logos or people's deaths before they actually happened, also known as false memories. Deja vu is the overwhelming feeling that you've seen certain stimuli or events or places before, even if you haven't. The word itself, déjà vu, comes from French and translates to already seen. But why do we experience these strange hiccups in our minds? What can neuroscience tell us about this phenomenon? And is there a way to hack our brains around it? Find out in this week's episode of The Neuro Nerd. Deja vu debuted as far back as 400 AD when false memories were first reported by St. Augustine when he wrote, quote, "For we must not acquiesce in their story, who assert the Samian Pythagoras recollected some things, which he experienced when he was previously here in another body, and others that they experienced something of the same sort in their minds, but it may be conjectured that these were untrue recollections, such as we commonly experience in sleep, when we fancy we remember, as though we had done it or seen it, what we had never did or saw at all." Art Funkhauser, who's a Jungian psychologist who specializes in deja vu experiences, believes that there are three types of deja vu. Deja vécu, which translates to "I have already experienced this", déjà senti, which is "I have already felt this", and déjà visité, feeling that a place is familiar though one has never been there. So essentially, he has parsed out deja vu via our senses, either through experiences, feelings, or physically being at or near the stimuli in question. This helps us form a framework around the types of deja vu that we have reported in history. For example, in recent years we've penned the term Mandela effect, which this term originated in 2009 by Fiona Broome after she discovered that, along with a number of other people, believed that Nelson Mandela had died in the 1980s, when he actually died in 2013. Most deja vu accounts for Mandela effects seem to be based on what we've already experienced, which aligns with Funkhauser's deja vécu category. For example, it seems like each year a new Mandela effect takes the internet by storm. Like, I remember the Fruit of the Loom cornucopia that didn't actually exist, or Jif peanut butter instead of Jiffy, and so many other ones that have come across my For You page. However, déjà senti, or the sense that you've already felt something, can also be traced back many years before this. For example, in Charles Dickens' 1850 book David Copperfield, we see this line in one of the chapters, quote, "We have all some experience of a feeling that comes over us occasionally of what we are saying and doing having been said and done before, in a remote time of having been surrounded dim ages ago by the same faces, objects, and circumstances, of our knowing perfectly what will be said next, as if we suddenly remembered it." So I think it's safe to assume that this evoked feeling has spanned much of human history and isn't just a new age zeitgeist phenomenon that's being made popular by different TikToks, but something more deeper and more complex than what pop culture can describe. So to help clear the air, let's talk about how neuroscience gives us a lens to understand this experience. There are a lot of theories on neuroscience surrounding deja vu. If we go back in time, we see that Hewlings-Jackson, who was a famous neurologist who worked pretty much exclusively with epilepsy patients, noted that some of his patients reported deja vu feelings more intensely before their seizures. So this led us to believe that these feelings were associated with underlying structures that were commonly affected by epilepsy, more specifically the temporal lobe. One of the most striking and impressive functions of this lobe is its ability to encode memory and language. Although a lot of this early literature focused on more deficit approaches to understanding deja vu, such as through epilepsy or other psychiatric disorders like anxiety, depersonalization, or depression, other researchers took to their research with a more broader conceptual understanding. In fact, we began to find that this phenomenon was quite common even among neurotypical folks. So Wild in 2005 wrote of a non-pathological deja vu, stating, quote, "The key discriminant in this setting is the patient's insight. Impaired reality testing, intrusiveness, and incorporation of deja vu into a delusional system may suggest psychopathology. Duration is also of importance. When deja vu is instantaneous and self-terminating, it is less likely to be due to psychopathology than if it is prolonged and cannot be terminated." Much of the literature agree that the temporal lobe is activated during déjà vu. These areas often boil down to the amygdala, hippocampus, parahippocampal gyrus, and the temporal neocortex, generally speaking. However, some researchers also suggest that limbic activation and movement are key pieces of activating déjà vu-like experiences, which was pretty cool to read about. One study by Glor and colleagues in 1982 implanted electrodes in epileptic patients, and they found activation in all the regions that we thought were important, all the ones that I just listed beforehand. But they also claim, quote, unless limbic structures are activated, experiential phenomena do not occur. Limbic activation may be essential for bringing to a conscious level precepts elaborated by the temporal cortex. Interestingly, some researchers also believe that it's a conflict between two brain processes. Aitken and colleagues in 2023 proposed that déjà vu is a conflict between familiarity and recollection, wherein the brain typically balances these two systems, but at times they go out of sync. This glitch activates the conflict monitoring system, where the anterior cingulate cortex detects conflict. The medial prefrontal cortex resolves it, and the hippocampus encodes that context, which then the perirhinal and parahippocampus track that familiarity. I know that's a lot to take in, but it's basically just one big loop, and their argument is that we know young adults tend to have greater experiences of déjà vu than older people, and they surmise that this is probably because this conflict detection and memory checking system are more active in younger populations. That loop is much more activated for younger populations. But as you age, you may not be more aware, or maybe you even ignore the conflicts easier because their memory not is worse, but because their memory has been turned on for longer. That monitoring system has been tuned. I think this is a super interesting idea that younger people tend to have greater déjà vu experiences. Perhaps this is because of greater neuroplasticity, for example. I think it's entirely possible that younger folks haven't yet pruned or made these circuits as effective as older people yet, probably because experience helps wire those connections. If you've ever been around neuroscientists or you're a researcher like me, you've probably already heard of the Hebbian law, which states that what fires together wires together. And I think it's entirely possible that that's what we're seeing here with déjà vu. And so my personal recommendation, based on this very narrow literature review, is that we simply don't know enough yet about neuroplasticity in these very niche concepts like déjà vu or the Mandela effect. And I think it would be super beneficial to look at this process longitudinally as well. And currently there's a lot of contention, I would say, around this idea of adult neurogenesis, meaning, is it possible for older folks to create neurons? And there's some competing literature out there that states that that is the case, but there's a lot of evidence that points otherwise. And so there's a lot out there that we just don't really understand yet. And I think longitudinal data is so valuable in that sense. So I think that it would just be really cool to look at more dynamical systems and models that we could use to look at the development of déjà vu experiences over time. And, interestingly, there is some indirect evidence that supports this line of thinking. A recent study by Cates and colleagues in 2021 tested the effects of stimulating the 5-HT4 serotonin receptor using a drug called prucalopride, and they found that it enhanced both memory, performance, and hippocampal activation. So, the hippocampus, of course, is deeply tied to memory encoding and retrieval, which are super important core mechanisms in what I would, I guess, quote as déjà vu experiences. But what makes this really relevant is that this serotonin activation is also known to promote hippocampal neurogenesis and synaptic plasticity in animal models. So if déjà vu emerges from conflicts in memory recognition, say when familiarity outpaces actual recollection, then that enhanced plasticity might help resolve or even prevent these conflicts more efficiently. And so that makes me wonder whether the frequency of déjà vu in youth is partly due to the brain being in the middle of this wiring and rewiring of itself, this plastic system that's still refining its thresholds for familiarity or memory accuracy. So can we neurohack this glitch? Can we hack déjà vu? Sort of. I mean, you can nudge the brain into that weird middle space between recognition and uncertainty. I think that we can trigger déjà vu through a variety of ways. Keeping a dream journal might help us prime our brains into the waking life, kind of like a cross-channel interference. Anytime that we disrupt that top-down processing, either through undermining predictive coding, through fatigue, for example, maybe you're also more likely to experience it. In fact, I think there's a lot of anecdotal evidence to suggest that caffeine and tiredness could increase the likelihood of déjà vu, probably because your brain has flooded those adenosine receptors. So you're alert, but not processing optimally. So I think that that also increases your chances of feeling these sort of déjà vu experiences. So in the end, déjà vu isn't just a glitch, it's a super fascinating window into how our brains balance familiarity, memory, and prediction. So whether it's tied to neuroplasticity, misfired recognition circuits, or just the chaotic beauty of a brain still learning how to interpret this world, it reminds us how fragile and flexible perception really is, and we might not have the research yet to fully know the neurocorrelates behind déjà vu, but by studying its mechanisms, we do come closer to understanding how we make sense of it. Didn't I just say that? I swear I just said that. Weird. Have a great day, guys, and I'll see you next time.